Hello, I'm Eric Snodgrass, and thank you for watching today's Ag Forecast brought to you by Nutrien Ag Solutions. We're going to start off by looking at a radar animation, and we're going to center ourselves right here on the storms that are going to come over this part of North Dakota. Now, this was not well forecast by any of our global models like the ECMWF or the GFS, and even our high-resolution near-term models like the HRRR or the NAM also missed on these storms. But I'd like to show you what actually happened here. As I play this long radar animation here, there was a boundary sitting right in through here that just very slowly moved. In fact, it didn't move much at all. And storms built down the back side of this boundary toward the west as they were fed with moisture from the south. Now, as I play it again, what ended up happening is several of these storms just sat here for a very, very long time. And as a consequence, there was hail, there was a lot of very heavy rainfall, and some localized flooding from these storms. And again, it was a situation where the morning of the event is when we started to see everything begin to unfold in this area. So very challenging forecast beforehand. From there, I'd like to take you to yesterday, Wednesday afternoon, and show you a satellite image that I grabbed here, where you're looking at the parts of the northern plains back into Montana. There was a very large supercell thunderstorm here that even on satellite, we could see the rotation of the mesocyclone on the backside. We think that the top of this storm, based on some radar echoes and some satellite imagery, probably was over 50,000 feet, and it produced a beautiful anvil shadow as the sun was setting. Now, to the south and east of that, smoke was spreading here across parts of South Dakota from the Bear Fire, which was caught on video right here. Some of the smoke plume, the pyrocumulus coming off of the top of that particular fire. So this was certainly an active day in parts of the high plains. From there, I'd like to show you what happened over the last 3 days, 72 hours of total accumulated precipitation. So here's the storms we just discussed. We can then see how much rainfall fell from the repeated thunderstorm activity over parts of the Mid-South. So clipping Oklahoma, but then going through central Arkansas, into Mississippi, some very, very heavy rainfall. And this, by the way, added to some very heavy rain that had been there lately. The upper level low that's been spinning here, that's just slowly moved its way through parts of the Ohio and Tennessee Valley up toward parts of the Northeast, has returned a lot of rain to places that desperately need it. But the rain that was coming through this area was just torrential. I'd like to take you over my Twitter feed to show you something. I'm going to show you a video from Brian Emfinger, and I'll play this. Let's actually just blow this up so we can see a little bit better here. This is some of the flooding he captured with his drone as this big shelf cloud was approaching. But we can see here in parts of Arkansas how wet things are. Thousands upon thousands of acres completely flooded out here. And I guess we're going to be getting in some of these areas a disaster declaration due to the flooding problems that we've had here. So just wanted to show you what this looked like here as we kind of move into this forecast. Now, this forecast, a lot of it is going to hinge on returning moisture to places that need it and avoiding getting moisture in places that have too much. And that's where we're going to come right back to this top 16-inch or top 40 centimeter soil moisture percentile map. Again, this comes from NASA. And what I want you to see is that right in through this area, our soils are very saturated. And of course, that's where the heavy rains just came through. But we're going to be watching later today for some severe weather to blow up here, and how much rain it spreads across this part of the western Corn Belt and the northern plains will be important for us to investigate here in a few moments. So feel free to pause the video and take a closer look at this image, because it's going to be one that we're going to watch very carefully through the coming days and weeks. Now, the pattern right now is looking like this. There's a broader trough off the west coast, and it builds up into a ridge here and then spreads out into the North Atlantic. This trough has kept the west coast cool for much of this week. I'm talking highs in the 60s and 70s after enduring triple-digit heat just, 2 weeks ago. The cutoff low we've been watching coming out of Texas is now here, still moving slowly, scattered storms all around this as it moves. But we want to watch, we want to watch the ridge that's going to end up forming on the backside of this for the next 10 plus days or so and see where that goes. I'd also like to make one last point. Down here, the National Hurricane Center was watching a little tropical disturbance that moved over parts of Central America. And there's some of the models want to bring the leftovers, the moisture from that, into the Bay of Campeche. Whether it redevelops or not is just too uncertain at this point. But if that moisture moves farther to the north over these areas that are saturated right now, we could be looking at some problems for flooding, more problems for flooding, because any additional rainfall in this area right now causes flooding. So our all hazards weather map right now, we have a lot of areas that are under heat advisories. These are flood watches and warnings out for parts of the Appalachian Mountains through the mid-Atlantic and down here in the mid-South. Red flag warnings, excessive heat, and we're just talking about hot, windy conditions with severe storms out ahead of it. And I want to show you those severe storms here in just a few moments because the Storm Prediction Center just made an upgrade early this afternoon. I'm recording this about 12:30 in the afternoon to now include this area under the moderate risk. And the big question I have is, what is the severe weather threat out of this? The answer, primarily going to come from strong straight line winds and hail, and this is mostly going to be late this evening and tonight. And then how far tomorrow, my second question, do these storms move into Minnesota and Iowa? Let's get some answers there. We're going to look at 4 different models today. We're going to start with the NAM model first. Now here in this pocket, right over in this part of the United States, the Ohio Valley, Tennessee Valley, Mid-Atlantic, Southeast, you're going to see as I play this forward, just watch that area first. That cutoff low through the day on Friday just continues to produce widely scattered storms. All right. But what I want to show you is that late tonight, we're going to watch right here, well, late this evening, for some convective initiation. That's where the storms are going to start, and then they're going to push across the Dakotas in the overnight hours. Now you can see that it appears to be one long kind of segment here, a long squall line. And that tells us where our primary threat's going to be, and it does this based upon wind shear. So this is a wind and hail issue. There will be storms in Montana as well. Notice that. And before all this gets going, we're going to watch northern Wisconsin too. All right. Now, as we play this into Friday morning, it appears that in the overnight hours, the storms continue to run to the east and spread through eastern South Dakota down into Nebraska. But at 5 a.m., these storms tend to lose some of their instability, especially, of course, they've already lost the surface instability. And as we go out into the morning hours, the very stable morning hours, the model attempts to break the storms up, sending a piece farther south into Kansas, but breaks them up as they go into parts of Iowa. And nothing really makes it past about Des Moines, that area. Meanwhile, the upper level wave pulls into parts of Saskatchewan and Manitoba tomorrow afternoon, producing more scattered showers and storms. And then we're going to watch late in the day for storms to fire along the broader front that will be associated here. 2 other things are going on. Still, scattered storms off in the east, and all of this is under that bigger ridge that's here with the cutoff low tucked underneath. So that's what this is. And maybe some very heavy rains for parts of North Carolina right in through here, where lately we have accumulated a lot of rainfall after being in drought in much of April and May. And then you notice out west, coming through Oregon tomorrow night, we could get some onshore flow here, bringing in some scattered showers and some thunderstorms. Well, let's just let this go through the day on Saturday, so your Saturday morning, and getting into Saturday afternoon. We see that front continuing to press forward, scattered storms along it with storms over the southeast and the onshore flow coming into the northwest. That's our setup through Saturday. That's model number 1. Model number 2 is the high-resolution rapid refresh. It's going to have a very similar story over the east, but I want to watch the system going through the northern plains. Ready? So this is this afternoon and this evening. Now, in the NAM, we'd already blown up a line of storms here, but the HRRR is just kicking off a few individual cells, and then later in the evening, this is now 12 a.m., this is midnight, that's when it has the main convective event, so it's slower. And then what ends up happening is the storms move across the eastern Dakotas, try to get into the Red River Valley of the north, but bring the storms like we saw, but just much later, through eastern South Dakota and Nebraska. Now, what's interesting is the high-resolution rapid refresh model continues the storms through mid-morning into Iowa, bringing in some scattered rain, but potentially, in some locations, a bit heavier. And if we just play this out through the day on Friday, the remnants of the storms go racing through parts of Kansas. Now, most other things on the HRRR are similar. What's going on over here at the east, the storms that we saw here across parts of the Great Lakes, and the onshore flow coming into Oregon. But that's our first 2 models looking at storm system just within the next 48 hours, really 36 hours, and you already see major model differences, which is why we watched the radar so carefully and now cast our way through it. Now, those are our high-res models. Our low-resolution global models, which are the GFS and the ECMWF, well, I want to show you their skill scores. I keep talking about it. This is what they are. Now, this graphic comes from my friend Ryan. And what he's showing you here, going back to late March through April, May, and early June, we see the ECMWF score in blue and the GFS in red. Now, we were doing pretty well through May 1st. And then getting into May, the average has dropped and it's stayed down here. And as of late, while there's been a lot of separation between the models, sometimes as much as 10% better in the European than the GFS, each run gives us a new difference. And the models have really struggled with this trough off the West Coast. So now let's take a look at what that means. We're going to first look at the 0Z runs. Now the 12Z GFS is out right now. And I'll tell you what it says. But the 0Z doesn't come out for another few hours. Or excuse me, the 12Z doesn't come out for another few hours from the ECMWF. So we're going to compare apples to apples here and look at the 0Z runs from today. We have this, the cutoff low. We have very dry conditions in here compared to normal. And the European model isn't picking up on that boundary sweeping through there, bringing in much precip. But the GFS is. And you can see here, wetter in that area and wetter here. Now, does it make it through, and do we return moisture to the very dry areas in Minnesota and Iowa? That's yet to be seen. And these models, just a reminder, they do not do well with convection. They're just not designed to do well with convection. Now, before I go any farther, I have to make one comment. It's what you see right down here. There it is in the GFS. If we go back to the European, you see this as well. Something in the Bay of Campeche. The storms that comprise the tropical depression that was here, now moving across Central America, well, the National Hurricane Center has stopped forecasting the probability of this developing. But the European model is trying to take what's left of this, get it into the Bay of Campeche, and giving it, a 30+% chance of just redeveloping. Could just be into a low pressure cell. But I'm more worried about the moisture it brings here, because the ground in this area is saturated. And a tropical system would be absolutely devastating at this time for that region, which means we're just going to watch. Because what I'm showing you here, this map, this is valid June 16th to June 19th. So it's got to move here first and then reemerge, and we just need to keep an eye on it. I'll talk to you about it again next week, of course. So from there, I'm excited to show you this. I got some time this morning to finally write some code that allows us to do side-by-side comparisons. And we're going to start off with the 500 millibar trough and ridge pattern, ridges being in red, troughs being in blue. The European model is on the right, the GFS is on the left. And I want to show you where the models have struggled with this current wave. So as we play through, this is now Thursday afternoon and evening, getting into that critical time period in the overnight hours. The first thing I want you to notice is this is a deeper wave, and it's farther to the east in the GFS than it is in the European, where it is a shallower wave farther to the west. Then as it moves through, look at the difference between where the models push the main area of lift. Now, out ahead of these waves, okay, that short wave, you have an area where we have what we call differential positive vorticity advection. And what that leads to is, on the eastward side of a trough, this little shortwave here, you get rapidly rising air. So that's going through the Dakotas in the GFS, and that same area is farther to the north in the European. And the European tosses that wave right here. Can you see the difference? It tosses it just north of the border more quickly tomorrow than the GFS does, which leaves it out here toward the Red River Valley of the north. What's the difference? The difference, we can just come back and look at it here. This is the European, and there's the GFS. So that difference in this, just the minute position change and inflection of that wave is what changes the precipitation. So as we go out through Sunday into Monday, Tuesday, we see a very large ridge developing, and the models are echoing one another. You can see a trough here in the GFS, and similarly, there's a trough on each coast in the European. Different magnitude though, but they've both planted a ridge over the four corner states, which means the heat's going to come back right there centered on kind of the front range of the Rocky Mountains. They then have middle of next week a trough that sneaks through out of parts of Saskatchewan over to Manitoba. But the downstream trough here along the east coast is much more extensive in the GFS than it is in the European. And beyond that, while they look like they have similar solutions, they diverge pretty substantially. Whereas the GFS parks this bigger ridge farther to the west, the European flattens it out and keeps it more centered right about 105th meridian. And this right here has me worried in the operational European. That's the leftovers of that tropical system that we just saw. So we'll keep an eye on that. Nothing is said about that. So if I can do this with these maps, we can also do it with these. Let's now compare the 0Z GFS to the 0Z ECMWF. And as we play this forward, they both pick up on the same convective pattern throughout the day today on Thursday here in the east. But what changes is as we go into this evening, the overnight hours, you see that the GFS kicks off the broader area of storms here, which is what we saw in the NAM and the HER, whereas the European, it's not shown up. And the rain is farther to the north. The European is missing this, okay? Just so you know, it is missing this convective event. But as a reminder that these low-resolution models aren't designed to do it. The European finally brings in the storms farther to the east, in time with the GFS. This is 7 a.m. tomorrow. And as we go into 1 o'clock on Friday afternoon, whereas the GFS breaks the line up a little bit, the European continues it through Minnesota and Iowa. Very similar to what we saw in the HER, okay? From there, both models allow this to break up before it gets to eastern Iowa. And the European continues the southern edge of it through just west of Kansas City. Meanwhile, storms continue to pop in this area. Now, I know I spent a lot of time just here on the next 48 hours, but this is a critical time period, and the rain coming through is critical. So let's just keep playing as we go through Saturday and Sunday, out into Monday and Tuesday. Both models attempt to bring in higher atmospheric pressure, the GFS and the European. And that suppresses a lot of convection farther to the south and gives us a week of, next week at least the start of it, where there's less convection, less storms. But the GFS tries to fire stuff up right here, and it's not really there in the European. That's Tuesday evening. Let's now get out here toward Wednesday. There's our high pressure cell again. And go from Wednesday out into Thursday. That's the low that we saw in the 500 millibar height field. Both models are attempting to produce that. It's Thursday morning, afternoon, and evening. And the differences beyond this, well, the GFS attempts to drag a pretty big front through, cooling things down, bringing in precip. The European doesn't have any of it. And that's some of the reasons why we have these major model differences. Both models are attempting to bring that moisture into this area. The GFS later and farther to the east, the European sooner and farther to the north. And that's the difference we're seeing at this point. So I can stack it all up and put it together, and this is what you get. This map compares the European model to the GFS, but only over the next 7 days. Wherever you see the green colors to the teal, greenish blue, whatever that is where the European is wetter. Wherever you see the yellows to reddish browns, that is where the GFS is wetter. So take a look at this and compare the two. What I want to do next is I want to step this out and go out there to day 10. The ensemble forecast is got this as a flow pattern in the European, the ridge being here. And as a result of that, it's got much of its precipitation confined here and partly along the high plains with more scattered storms in the eastern Corn Belt. This is the remnants, though, of the tropical system we talked about. Now, we're not yet into the time of year where northwest flow like this is going to help initiate a lot of storms. That typically happens when you get into July and August and September. It's not that it can't happen now. It's just not yet there. I'm going to wait for that 588 line to make it a little bit farther to the north than this. But if we just look at it again, there's week 2. Now, the GFS model, a little different projection, but the same thing, has very similar flow. There is a ridge here, although it's a bit more extended in this area. But look at the difference in the precip patterns. It too has the high plain storms, but it's much drier, especially over the southeast. It also has what was left of that tropical system bringing in moisture into this area, which again, I'm concerned how far that makes it to the north and to the east. So we've got a lot to be watching here just over the next couple of weeks. From there, let's talk temperatures. We're going to walk through the next few days here by looking at high temperatures. It is a scorcher today in this area, whereas the West Coast continues their I'll call it cold. This is a cold week in California for this time in June. But as we go into Friday, cool down happens here, but it is very short-lived. Heat out ahead of it, cooler along the Appalachian Mountains into the southeast. As we go from Friday into Saturday, the ridge begins to build. A lot of summer-like warmth across the United States here. That's as Monday's highs, Tuesday, and Wednesday. And remember, at this particular time period, The jet stream pattern has that large ridge here with a trough over the east. And so we got this cooler band of weather. When I say cooler, it's a couple of degrees cooler, with all of the heat anchored here over the northern plains back to the high plains of Wyoming and Colorado. Something to be said here. After the precipitation comes through, which we're going to witness over the next 48 hours, if the temperatures go back hot and we pick up some windy conditions, we could evaporate a lot of that water, which would not correct our longer-term drought scenario. So this all must be monitored very carefully. Day 5 through 10, you can see where the ridge is anchored and the heat that spreads all around that ridge. I want to look back quickly at the time period of May 1st through June 10th, because what you're looking at next is the temperature ranks. And you've noticed that in a lot of the forecasts along the Gulf Coast in the south, it remains a cooler forecast, and it's been quite cool. Some places down there having a top 5 to top 10 coolest such time period on record, while the heat's really been pushing back to the west at times. Over the next 30 days or so, let's take a look at it. This is the end of the month of June, getting to the 4th of July. Very warm because the jet stream is pretty far to the north. We can thank some of the big ridges we've had so far this year for pushing the jet stream farther to the north early. But as we play this forward, you see that getting into mid-July and then toward even the third week of July, that's how far out the weeklies go, we just continue to see the above average temperatures due to the more northward position of the jet stream. And just a reminder, the weaker the flow and the farther to the north the jet stream, the more the pattern favors thunderstorm development rather than low pressure development. And that's always going to be hit or miss on those thunderstorms. I want to add a new dimension to this today. You've probably heard lately a lot of atmospheric scientists discussing something called the Pacific Decadal Oscillation. We're going to define it, but we're going to first take a look at its pattern. It is a decadal oscillation. And going back to the 2000s, really reaching a peak around 2011, 12, and 13, the PDO was very negative. It then rebounded in 14, 15, 16, 17, and 18, and has since dropped back down, and right now is sitting here, lowest point it's been since 2013. So what is the PDO? How does it relate to other stuff we've been talking about? Well, we're going to answer that by looking at ocean temperatures. We've talked a lot about this, and that is a part of the negative phase of the Pacific meridional mode. But when the PDO is negative, this whole area tends to be cool, whereas this area tends to be warm. So we're cooler in here and warmer in this region. That is what the negative phase of the PDO, Pacific Decadal Oscillation, looks like. Now, why we concern ourselves with this is because this is its relationship with precipitation across the United States. Now, the correlation is positive where there are warm colors and negative where there's cool colors, which means if we had a positive PDO where it was very warm along the west coast, we would be very dry here and wet in this area. But we don't have that. We have a negative PDO, which means our heat and dryness risks are here, and this area historically is correlated with wetter conditions. Now let's try to blend this together with what's going on with La Nina. And I did say La Nina because the latest updates from the European model, instead of opening up this plume to the possibilities being quite large, they've now kind of honed things in a little bit. And the likelihood of remaining INSO-neutral to possibly even into weak La Nina territory late this summer and through fall has increased. It's kind of a double hit on La Nina last year and then possibly a rebound this year. What does all that mean? Well, let's go look at a few different things here. Remember how I showed you the PDO would favor wetter conditions here? This is the latest forecast, which I showed you last video for July, August, September, and it was drier in this area. Looking at the ocean temperature patterns, let's just step this out and look at an equatorial view. We do see that the models are attempting to keep this area near normal or cooler with a large warm blob in this area. Now that seems to line up well with keeping this PDO negative, which means we just come back to the risk through this area of drought development. And that doesn't change our story much over what we've had. It's just a new piece of information. But what's new is what just came out from the National Multi-Model Ensemble. This model is also attempting to keep the northern tier of the U.S. and southern Canadian prairie, and much of Canada, I should say, warmer than normal. And it was initiated cool here and is continuing that bias through July, August, and September. But what is this model doing with relationship to what the European did? Because remember, the European was wetter here, July, August, September, and trying to favor drier conditions there, right? Maybe I should draw that again, right in through here. Well, the latest NMME backs the driest conditions farther west than it had done. It used to have these drier conditions much farther over to Iowa and Illinois. Now, it's a long-range model forecast, which means the chance of it having high skill and accuracy is limited, but we watch these trends just to keep tabs on things, all right? So, had a lot to talk with you about today, but let's take this and kind of run with it and understand how this pattern is going to change, and I'll bring it all back to you on Monday, okay? Have a good week, and we'll talk to you then. Thanks.